When an object enters a black hole, its ultimate fate is currently unknown. According to our current understanding of black holes based on general relativity, the gravitational pull of a black hole is so strong that it traps everything, including light, within its event horizon. The event horizon is the boundary beyond which nothing can escape the black hole's gravitational pull. As an object approaches the event horizon, the gravitational tidal forces become increasingly stronger, stretching the object in a process known as spaghettification. The object would be stretched into long, thin strands as it gets closer to the black hole. Once an object crosses the event horizon, it is thought to be crushed into a singularity at the center of the black hole. A singularity is a point of infinite density where the laws of physics, as we currently understand them, break down. At this point, our understanding of the object's fate becomes limited. It's important to note that while this is the prevailing understanding based on general relativity, the physics at the center of a black hole is not well understood because it involves the combination of gravity and quantum mechanics. The true nature of what happens to an object inside a black hole is still an active area of research and a topic of scientific inquiry.